Hello world, this is installment 2.1 of the development vlog for the AARDVARQ multiplayer roguelike game. I recorded an installment 2, but it was 3 hours long and I'm having some difficulty with the editing. If you're watching this far enough in the future, maybe future me has figured things out and published installment 2, but for now, present me will just do a quick review of the new maze generation code. The new code is pretty well self-contained in the new maze level class, which implements the level creator interface that I introduced in installment 1. I have an internal data type for tracking maze ends, the point at which the maze terminates at that location, and the distance from the start. The create new level method creates a level 101 tiles square. Typical levels currently are 100 tiles square, using 101 as an odd number allows the floor spaces to be fully surrounded by walls on all sides. Pick a random point in the level to start the maze. Generate the maze via the generate via DFS function, which I will explain in more detail shortly. Set an up staircase at the starting point of the maze. Search through the maze ends to find the end that was furthest from the start, and set a down staircase at that location. This method is not fully implemented at this time, and I've left the add stairs method present and commented as a reminder. Currently, this only allows for one up staircase and one down staircase. I need to support an arbitrary number of up staircases and down staircases. So that is future effort. This code has been successful at generating a maze, which was the primary goal of installment 2. The actual maze generation algorithm is the randomized depth first search algorithm, also referred to as the recursive backtracker algorithm. It's fairly straightforward. For a given starting point, we look for all neighbors of that point that are not currently in the maze. This code determines if something is in the maze or not by whether the tile has been set to a floor tile as opposed to a wall tile. But that's the main point, is just determining if something is in the maze or not. As long as there is a neighbor that's not in the maze, we add that neighbor to the maze and continue. Although that's actually what's happening down here. If we didn't have a neighbor, we actually back up. Maybe not doing a very good job of explaining this. So we find our neighbors. If we didn't have a neighbor, we back out. If we did have a neighbor, that's the next important piece. So we pick one of our neighbors at random, and we connect that neighbor to our starting cell, and then we move to that neighbor as our new starting cell and repeat the process. When we reach a point where all of our neighbors are already part of the maze, we rewind. We rewind until we have a neighbor that isn't part of the maze yet, and proceed with the process of moving to that neighbor and going down that path.